In this experiment, I estimated the mass of a black hole by analyzing observed data. This was achieved by using Newton's second law, F equals ma, which translates to F is equal to dp over dt to find the net force. We could find dp over dt based on the position data. And then I used Newton's law of gravitation to solve for the mass of the black hole. Since the force of gravity was the only force acting on the star, I was able to set the gravitational force equal to the net force and then solve for the mass of the black hole, which is a variable in Newton's law of gravitation. Our lab was done completely in Python since the trajectory of the star was given. Thus, through our code, we were able to determine the black hole's mass, which was 3.98 times 10 to the 31 kilograms. I started by setting the initial conditions and reading in the coordinates from the CSV file. Next, I calculated the velocities by looping the subtraction of the initial positions from the final positions and dividing by delta t. Then I started another loop in which I calculated delta v and delta p. Following this, I divided dp by dt to get dp over dt, which according to Newton's second law is equal to the net force. Then, we focused on the parallel and perpendicular components of the rate of change in momentum, which are equivalent to the F-net parallel and perpendicular components. In the next block of code, p hat and d magnitude of p over dt are calculated and used to find dp over dt parallel, which is in turn equal to F-net parallel. Then, since dp over dt is equal to the sum of its parallel and perpendicular components, I found dp over dt perpendicular and in turn F-net perpendicular by subtracting dp over dt parallel from dp over dt. Finally, since the black hole is the only force acting on the star, we can set the magnitude of the gravitational force equal to the magnitude of the net force, which allows us to solve the equation for the mass of the black hole, which is done in this line of code. When the code is run, it shows the orbit along with the net, perpendicular, and parallel forces acting on the star. What does it mean? In your analysis, you should discuss how F-net perpendicular, F-net parallel, and F-net are different from dp over dt perpendicular, dp over dt parallel, and dp over dt. While it is a law of nature that F-net is equal to dp over dt, F-net is not the same as dp over dt. F-net is the cause, and dp over dt is the effect. Thus, this is also true for the parallel and perpendicular components. What if, imagine the black hole whose mass you found was removed and a different black hole was placed in the same location. Assume the motion of the observed star remains unchanged and is affected only by the gravitational force of the new black hole. Could you tell the difference? According to Newton's law of gravitation, the mass of the black hole is directly proportional to the magnitude of the gravitational force. Thus, if the mass of the black hole changes, the force of gravity will change proportionally to the mass, which will cause F-net on the star to change, which will finally cause dp over dt to change. Since the parallel and perpendicular components can be treated separately, both do not have to change. Thus, if only the parallel component change, the direction which relies on dp dt perpendicular will not, and the orbit will remain the same. However, we would be able to tell the difference because the change in speed of the star would be different. Thus, in this lab, we were able to use Newton's laws to find the net force on the star through analysis of the position data, and by comparing the net force with the gravitational force, we were able to calculate the mass of the black hole.